ladies and gentlemen, and welcome to another edition of What's Happening. I'm George Binns, and I'm here with my co-host, Elliot Margolis. And we're at part 3 of the discussion of global warming, the other side, with Frank Bellini. Welcome, Frank. So can we continue where we left off?
Absolutely.
What would you like to start with?
I'd like to start by sharing my screen because I want to make a point here up front that the kind of information that you need to take a look at the other side of the issue here is not all that readily available. So if you do a Google search or any other type of internet search on global warming or climate change, you're only going to get one side of the issue. So let me give you some resources here. That's it. Is that it? That's it. Okay, you're seeing that list?
Yep.
Okay. So the folks that really delve into this and make it their passion are headed up by a guy by the name of Tony Heller. And Heller has mostly a science bent, although he mixes in a little political science once in a while. And you'll find his videos on YouTube, at least for the moment, until they cut them off. But his website is realclimatescience.com. But if you're taking notes and you want to write down Tony Heller and do a search, you will find him readily. There is a website called Climate Realists that has a long history of putting up this sort of information. They're no longer maintaining that website, but all the information is still up there. And you can find them on Twitter with their Twitter handle @ClimateRealists. Dr. Roy Spencer also does an excellent job of placing arguments out there and putting information out there. And he has his own website at drroyspencer.com. And finally, Dr. John Robinson, the Climate Discussion Nexus website, does a good job of it. And at the bottom here, I got to scroll it up a little so I can see it. Albert Hubbard, kind of an old-fashioned name, but he has a very contemporary website called What's Up With That? And he gets a lot of back and forth argument on there. He's also has a pretty good presence on Facebook, if that's what you do, and you can search Facebook for What's Up or What's Up With That. And you will find the kind of information that I have presented to you today and in previous videos, probably better done than I'm doing it right here by guys who are prepared and have been doing this for years and years. That said, I want to go back, step back a little bit to take a look at some information that I had presented before. And what we'll do is we'll just hop right up to the top of this set of slides and take a look at sea level conditions. If really and truly the Earth were warming, we would expect the polar ice caps to be melting. And given the rate at which we're putting out CO2, which is kind of parabolic these days, we would expect the melting to be accelerating. And so sea level rising commensurately. In point of fact, the trend of sea level has not changed for over 200 years. We can look back as far as the Lincoln administration and see that we have the exact same trend. Now, this is a graph from a station called the Battery. It's Battery Park at the southern tip of Manhattan in New York City. And you can see that there is no influence on this trend by any outside factors, any outside forces. It's the same as it was prior to the Industrial Revolution. And you say, well, why Battery Park? Why New York? New York is pretty stable. You don't want a place where the ground, as a result of tectonics or other reasons, is moving. And New York is a fairly stable location. There are people that argue that it isn't, but I believe that it is. If we move on to a spot in the Pacific, and by the way, this is all NOAA data. So this is all collected by the National Oceanographic and Atmospheric Administration in the U.S. And they keep this. And this particular chart for Fort Denison, Australia, has been annotated by someone, which has divided the time period that goes back to 1880 here, or really 1885, I guess, for the beginning of the data, as anthropologic, meaning the time period which, if man were going to have some influence, it ought to show up. A period of natural conditions where there shouldn't be any influence, and a period of mixed conditions where we kind of coalesced from natural conditions to potentially man-affected conditions. There's no change, absolutely no change. So, I look to these guys and say, maybe this is indicating a warming trend here. As sea level goes up, how do your climate models look back at this period of time and show temperature really not increasing very much? When we get these predictions from climate models of 2, 3, 4, 5 degrees increase over 20, 30, 40 years. I worked with mathematical models in my background, not climatological models, but I worked with groundwater models, and I worked with radiological dose models. And they're not the easiest thing in the world to work with. You plug in the variables, you run it, you get some results, you go back and you plug in different variables and you run it again until you get results that kind of make sense. Or in the case of climate scientists, results that fit their model, which is that CO2 is the control knob of climate for the planet. I dispute that vociferously, by the way. CO2 is 0.04% of the atmosphere. And while it does have some warming effects, those effects overlap almost completely with the effects of water vapor, namely clouds. So any greenhouse effects from CO2 will be completely masked by the overwhelming greenhouse effects of water vapor in the atmosphere, clouds, if you will. Anyway, back to sea level. And this just gets into what we're going to do, I think, in our discussion next week with someone on the other side of the issue. But here is one more sea level curve, this one from Honolulu, Hawaii. Again, NOAA data. But in this case, someone has plotted CO2 here, and here's the CO2 axis with about 300 parts per million here. Again, that would be 0.03% of the atmosphere, and up above 400 parts per million here, 0.04% of the atmosphere. You'd have to talk a long time to me to convince me that that trace amount of gas would control the climate of a planet. At any rate, you can see CO2 rising significantly here, and it's really gone kind of parabolic, depending on how you plot the X and Y axes. But absolutely no effect on sea level, none whatsoever. And those dire predictions from back 10 or 12 years ago about the Maldives sinking into the ocean and New York City getting flooded out. It's nonsense. It's just it has no meaning to it. It's only alarmist baloney, in my opinion. So we'll talk about this a little bit more next week. But the graph I really wanted to get into is this one right here, and talk about for a little while. We talk about sea level. The curves you've been looking at, the last three, are essentially this portion of this graph right here. So the slope is a lot steeper here, but it's steeper because we've messed with the X and Y axes. So it's essentially the same rate of rise that we were talking about for the other three locations. Prior to that, the data gets pretty messy. It kind of goes sideways. There are a few little uptrends, there are little downtrends. And people will argue that the warming started at the low point here at 1800 and kind of went up, but it went sideways for a while. So you say, well, what's causing all this? Well, here's where CO2 started to come into the picture as more relevant, I'll call it. So, 0.04% of the atmosphere as opposed to 0.03% of the atmosphere, if you want to call that significant. What happened here? I don't know. You can go to Joanne Nova. That's another good site, joannenova.com.au. She's an Australian that follows this stuff and studies this stuff. I probably should put her on my list. But clearly, all of this is natural. The only portion of this curve that is potentially man-made is right this very tip right here, the last little wiggle that you see on that curve. And it simply makes no sense to me that we follow this last little wiggle, essentially the noise of this rather than the signal here, and let the tail wag the dog and worry about something like a Green New Deal where we want to bet trillions of dollars on man being able to stop natural climate change. So I'll pause there for a minute, and I'm going to switch to another slide when you're ready.
Okay, could you stop sharing?
Yes.
Take the slide down. See if I can put up one.
Okay.
Let's see, can you see anything on the screen?
Yes, I think so. It's not that big, but
Why is it not big?
I gotta.
I can't. Where is it going?
I can see it. X-axis years before the present, Y-axis relative sea level.
Yeah.
Yep.
Okay. This goes back to essentially the end of the last glaciation period. And this is the rise in sea level since then.
Right. Essentially the curve that I just showed you.
So this is in meters.
Yep.
So 120 meters is about not quite 400 feet.
Right.
And when the ice melted, yeah, there was a lot of water added to the ocean, and it got up to, pretty near where we are now. And for the last 5,000 years, it's been pretty flat. And the number I keep coming up with is about 1/8 of an inch per year. And it's changing, but it's not something that's going to be that dramatic.
Right.
So
you're talking about a foot in 100 years to kind of put it in round numbers that an American can understand.
Yeah.
At the rate we're going now, will it change? It may. It certainly has before.
Yeah.
Let me show you some temperature data that has given pause to the folks who do climate analysis. These data represent something called the pause. And this has given fits to climate scientists. Essentially, Earth temperatures, it's not that easy to measure the temperature of the whole Earth because we don't have a good distribution of thermometers, to put it in the colloquialism. And those thermometers are not always in the best place to measure temperatures. Nevertheless, here are two data sets, one from this remote sensing outfit here, and the other from University of Alabama, Huntsville, and they coincide pretty well. You can see the darker line, the red line here, and the lighter line here sticking out here below it. If CO2, and I showed you the CO2 curve before, superimposed on one of the curves from sea level rise in Hawaii, if indeed that curve was influencing, that increase shown by that curve was influencing climate, we would not get a 15-year pause. Let's see, what is this? 1995 to 2015. So a 20-year pause. Am I doing that math right? Correct me if I'm wrong. Excuse me. And this has given people fits. And people like me, who are called skeptics, I prefer to call myself a climate realist. The realists say, well, what happened, guys? What's the problem here? Why hasn't the warming continued through the latter piece of the 20th century here and into a good piece of the 21st century? Until that question is adequately addressed, you will never get me to acknowledge that the models are giving us the right kind of information. Now, let's see. Here is I gotta change the zoom on this just a little bit so that it'll all get into the picture. Let's go to 70%. There we go. I think that'll do it. This represents the data developed by climate modelers. This represents measured data, and I'm not sure it hasn't been tampered with, because there has been some data tampering here too. If you recall back to, about 10 years ago, the whole ClimateGate scenario came out, and emails among these guys were published. And some of those emails talk directly about manipulating data sets in order to have the data better fit their idea of where climate was going. At any rate, here's what the climate models predict, this spaghetti up in here. Here is what, in fact, is being measured. So are these climate models any good? Not as far as I'm concerned. They look pretty weak. If I had mathematical models giving me these kinds of results, I would be calibrating them to the real data to make sure that they're giving me results that are consistent with data actually measured on Earth. And it ain't so. It ain't so.
Well, once you get into the question of data and measurements, the obvious question is, where do you stick the thermometer to measure the Earth's temperature? And
Yeah,
basically, there is no answer. You start to think about, how do you get a temperature measurement for the whole Earth when 70% of the Earth is ocean, and of the land mass that's left, only 10% of it is occupied territory. So you've got a very, very small data sample that you're trying to average into a heck of a lot bigger area.
The answer is
one of these things that I got questions that I just don't have good answers for.
The partial answer is that you get to fudge the data afterwards. So if you have, for example, a data set from ships at sea that are measuring temperatures out there, so that you kind of get some coverage for the 3/4 of the planet that is ocean, as opposed to the 1/4 of the planet that's land, you can take a look at that data and say, what do we think? Can we verify and validate this data from this ship or that ship, or this ocean or that ocean? And was there a storm going on? And what was the time of year? Was it winter or summer or fall, or was it an unusually cold or an unusually warm winter or summer? And so you get to fudge the data. And I think that's where they got the idea to do a lot of this fudging.
Well, one of the things that bothers me about this issue of ships at sea, Don Kent used to complain that the reason his weather forecasts were bad were because he didn't get a reading from a ship in the South Atlantic. So eventually he badgered the government enough and they put a weather ship in the South Atlantic. And I was still shoveling 6 inches of his partly cloudy. So, Elliot, you were going to say.
Frank, you were
Elliot.
you hear people saying that the temperature of the oceans is rising. That's why you hear that Antarctica and the Arctic are losing ice.
Yes.
But the question I have is, what about the underwater volcanoes? Do they have an effect on changing the temperature of the water, and how significant would that be?
Not really. You've got a massive dilution factor in terms of adding in that, well, it's a large amount of heat locally, but a very small amount of heat, even regionally, to say nothing of globally. So, in Antarctica, there are subglacial volcanoes. And in point of fact, some of the melting of ice reported recently as climate related was found to be the result of subglacial volcanic eruptions, which of course we can't pin on climate change or man's activities. So there definitely are other factors like that you need to consider and decide whether or not they're significant. I'm trying to think of another instance of that, but there are subglacial volcanoes in Greenland too that have had that same sort of effect.
Yeah, the Mid-Atlantic Ridge is just one giant volcano that runs from Greenland all the way down to Tierra del Fuego on the tip of South America.
Iceland sits immediately astride the Mid-Atlantic Ridge. So if you've ever been to Iceland, I have. It's a beautiful country to visit. Very interesting. Everybody drives cars like crazy. And when I asked about it, they said, well, we don't pay anything for heat. So everybody can drive around as much as they want. They have a lot of money for gas. I don't know where they go, but
well, we're getting down to the 5-minute mark, and I think it's time to start thinking about how would you sum all this up? What do you think the big picture is?
Well, it's difficult to find a big picture summary that's well written and palatable for the average person on the street to understand. I was talking to my sister-in-law about this, who's 85 today, and called me and said, what are you doing today? And then I told her, and I tried to explain it to her in 10 or 15 minutes. It's really tough. You have to get into the weeds. You have to do a little research. You have to listen to the other side of the story. For me, those sea level curves threw me over the edge. We were doing flood studies for nuclear power plants along the coasts of the United States. And we asked the NRC, how do we factor in sea level rise from here on out for the next 40 or 80 years or whatever we're licensing this plant for? And they said, just use that battery graph. And we said, but that's just a straight line graph. They said, yes, absolutely. That's what you use. That's the data. So there was no incorporation of modeling results or anything like that we had to do. And the federal government, and this was back in the 2010, 2012 time range, they were on board with what I'm talking about right now. So what I could say, if you're interested in this subject, do your own research. Go to those websites that I gave to you at the beginning of this George, I think, will post this on YouTube, and you'll be able to go back and review it if you can get that link and get into it. It's a fascinating subject, and there's a lot of good work being done, a lot of bad work, a lot of good work being done on it. And it will come to fruition in the next couple of decades. I can guarantee you that.
Okay. Elliot, do you have any final words?
Well, I'll tell you, I'm just fascinated by this and learning an awful lot, Frank. You bring an awful lot to the table to think about. And I just, I was sitting there, I can't believe the half hour is over already because, you know, you just went on with these graphs and listening and learning. I really appreciate the time you spent into this, and I appreciate what you've done for us. This is great information.
Well, this is my passion. Some people say this is caffeine for me. And I have to agree.
Okay. Well, ladies and gentlemen, thanks for watching. And as we've indicated, this has been 2 shows on the side of global warming. We've done 3 shows on the other side. We're going to do another show in the near future where we get both Frank and Kevin together. And I'll try to keep my 2 cents out of it, but I doubt if I can hold back. So there's going to be some more discussion, and stay tuned. And again, if you got any questions or if you got an opinion you want to voice on the what's happening, hey, we published the email addresses for Elliot, me, and Gail. Send me an email and we'll get you on the show. And again, thanks for watching and appreciate you following the shows.